All right, so this is going to be a review for chapter 14, sections 1 through 3. So everything that we talked about for angles. So we're going to go through the review worksheet, which should be in your notes packet. We're probably going to do close to all of them. We might skip a few to have you finish up, but we're going to try to go through all the big ticket items that we've talked about for the chapter. So first thing that we did was we talked about drawing angles and being able to represent those. So we're going to draw 160 degrees. And remember, if it's a positive angle, we talked about what that means. You're going to be going counterclockwise, and then in standard position means your vertex is at the origin. That initial or starting ray is on the positive x-axis always. And think about your benchmarks here. So we have 0, 90, 180, 270, and 360. So when we go all the way around, one complete revolution. 160 is going to put you over here into quadrant 2, almost to 180 there. So remember your direction arrow, super important, so you know it's a positive. And I would go ahead and label it with 160 as well, just to be sure that people can see what your angle measurement is, because we're not using a protractor. We also talked about the idea of co-terminal. Co meaning share, terminal means the ending side. So being able to find an angle that also ends up with the same location in quadrant 2. So remember how we do that. We just go around the circle again in either direction. So if you want to find a positive coterminal, you would take your angle measurement and add 360. Because 160 is an easy angle to work with. It doesn't take too much to do that. So if we add that together, we get what, 520 degrees? If you want to find a negative angle, we can go the other direction. So we can subtract 360. And that's going to give us an angle that's negative. Sometimes you might have to add or subtract more than once to be able to get an angle that's positive or negative. You can do it as many times as you want. Remember, there's infinitely many angles that are coterminal. So if I graph 520, for example, that means I would go all the way around the circle once. That would be 360 plus another 160 more, and I would end in that same, location. If I did negative 200, that means I would start same location here, and I would go negative 200 degrees in the opposite direction. I'd end up in that same location. That's what coterminal means. So making sure we can find angles that end in the same spot and be able to draw. So remember, negative angle, we go counter or clockwise, and then positive angles, we go counterclockwise. I'm going to let you do 2 on your own, so we're not going to do every single one. We're just going to hit highlights. You're going to go back and finish these up. We're going to talk a little about complements and supplements, make sure people remember what that is. So a supplement are 2 angles that add or sum to 180, so add to 180, and then complements, those 2 angles add to 90 degrees. So just remember, C comes before S, 90 comes before 180. Maybe that'll help you remember which one is which. So if you're going to find the supplement of an angle whose measure is 23 degrees, that means you would be doing 180 minus 23. So to find its supplement, just subtract. So we'd subtract, and that gives us, looks like 157, which would be letter D. If you're going to find complement, just want to make sure you're okay with complement here. And it's degrees and minutes. So sometimes you'll have a degree minute. Whatever your units are in, you want to write your answer that way. So when you do 90 minus 33 degrees, 25 minutes, let's make sure you know how to deal with that on your calculator here. So we're going to do 90 minus 33. And remember, you have to go to your angle menu, degrees, and then 25 back to your angle menu, minutes, and it's going to give you this as degree as a decimal. Now that's not the same as degrees minutes. You want to make sure we can get it back to there. So we again go to our angle menu to degrees minutes seconds, which is number 4, and press enter. Even if you have a scientific calculator, you still have those menus, and you can do the same thing. So 56 degrees, 35 minutes. So make sure you know how to use your calculator. If you have questions on that, that's really something that we need to make sure that you're feeling okay with. So we had 56 degrees, 35 minutes, which looks like that would be letter B. All right, now we talked about angle relationships and solving equations. So let's take a look at number 5. Complementary angles whose measures are 4x and 5x minus 27. If they're complementary, remember they add to 90 degrees. So that means this 4x angle and the 5x minus 27 together add up to 90 degrees. If I would have said supplementary, they would have added to 180. It's just a matter of expressing the situation with an equation. So I would just solve for x. So put together your like terms. So 9x minus 27 equals 90. Go ahead and solve that for x. So add 27. So 9x equals 117. Divide by 9. And looks like we get x equals 13. All right, so is that the angle measurement? Well, no, that's not the angle measurement because that's what our x value is. We still have to plug that 13 back into both of those expressions to find our two angles. So be careful. That first answer is like, ooh, it looks like it's that one. No, it's not. We got to plug the 13 back in. So we would do 4 times 13 for the first angle, and we do 5 times 13 minus 27 for the second angle. So make sure you substitute back in. So 4 times 13, that's 52. And it looks like there's only one like that. This angle would be the 38. So make sure you substitute back in. That's really important when we're using those equations. All right, so I'm going to go ahead and let you do number 6 and number 7 just on your calculator. And again, you're just typing in using your degrees minutes. So just go ahead and do those operations. Hopefully that shouldn't be too terrible for you. Remember to change over for 8 and 9. You're starting in one of the forms and you're going to the other. So take a look at this one. This is degrees, minutes, seconds. They want you to change it to degree as a decimal. And that's just a matter of typing it in. I will show this one to remind you of where seconds are. So it says 137 degrees. So go to your angle menu, grab degrees. 54 minutes. So go ahead to your angle menu and grab minutes. And then 9 seconds. So remember, they didn't put seconds in the angle menu. If you have a scientific calculator, it's in your angle menu, which kind of makes sense. Degrees, minutes, seconds are all there. For graphing calculators, it's actually above the plus sign, and it's alpha plus. So just be careful that you know where that is on your calculator. And then for me, I just press enter, and on the scientific, it's the same idea. Just enter it in, press enter, and you have it as a decimal. And just follow the rounding rules for this one, right? So it says they want you to round to the nearest hundredth of a degree. That's 2 places after. So 137 point, and if we look at our graphing calculator, it was 0.902. The 2 isn't big enough to round that 0 up to a 1, so it's just 0.90, which looks like letter C here, huh? So when we're going that direction, it's just a matter of being careful when you round. If you're going from degree as a decimal, so take a look at number 9, degree as a decimal, see how it's all in degrees, and you want to change it to degrees, minutes, seconds. That is really quick on your graphing calculator as well, just to illustrate that super fast. So if we type in 327.81, we're just going to go to our angle menu and change it to number 4 here to degrees, minutes, seconds. Scientific calculator is the same thing. And we have a real easy way to change that over. So 327, 100 degrees, and then 48 minutes and 36 seconds. So it's a pretty fast switch over there. So just make sure you're okay on how to type things in. Okay, let's get into some more of the applications here. We're going to talk a little bit more about coterminal and relationships between things. We'll do a little bit of application here. So remember, coterminal means it ends in the same location, and to find them, you either add or subtract 360 degrees. And again, sometimes you have to do that many times to get where you need to be. So for number 10, if they're saying the smallest possible positive, that's basically the easiest way you can write the angle. 11 or 13, whatever it was here, I think it's, make sure we have the right number there. 11 or 1311. If we're starting there, that's really big. So I'm going to have to subtract 360 multiple times to get it down to an angle measurement that makes sense. So I'm going to go ahead and start with that 1311. I'm going to subtract 1 complete revolution. That gets me to 951. Well, I got to do it again. That gets me to 591, getting closer. I got to do it again. Oh, 231, that's an angle that I recognize. The smallest positive means if I tried to go again, I would be a negative angle, so I've gone too far. So I need to subtract 360 3 times. That gets me down to 231. So I'm actually doing 3 360s, and that gets me down to 231 degrees. By the way, I'd want you to be able to identify too what quadrant that's in. If you were going to graph 231, so remember standard position, 90, 180, 270, 360. If you were going to graph this, 231 would put you down here in quadrant 3. So just realize, make sure you know where those angles would end up. Number 11, I'm going to have you do to find a positive coterminal. If you're already in the hole, guess what you're going to have to do? add, right? We got to get out of that hole. And if you're even more in the hole, just keep adding until you get to the smallest positive. It's just the easiest number to deal with. All right, let's take a look at a couple applications. I know you're going to see this on Math Excel as well. When we talk about things that rotate or spin, we're looking at those complete revolutions. It's a great application of angle measurements. It says a wheel is rotating at 480 times rotations here per 1 minute. They want you to figure out how many degrees does a point on the edge of the wheel move in only a quarter of a second. So how many degrees does it go? Well, first of all, let's see how many rotations it makes. If it can figure out how many times it goes around the circle, I'll be able to figure out how many degrees that is. But they're telling us in seconds and they're giving it to us in minutes. So the first thing that we're going to have to do is convert this into how many times does it rotate per second? So I can see what that is, because right now it's per minute. So we need to do a little conversion here. So we're going to multiply by our conversion factor. How many seconds are there in a minute? Well, in 1 minute, there are 60 seconds. So if I multiply 480 over 1 times 1 over 60, or in other words, 480 divided by 60, I'm going to see how many rotations there are per second. So 60 divides into 488. So that would be 8 rotations per second. All right, well, I'm not even going a full second though, am I? I'm only going a fourth of a second. So I need to figure out what that would be. How many seconds would that be? Or how many rotations would that be? So if it's a fourth of a second, so it'd be 1/4 of 8 rotations per second. So that would be what, 2 rotations? And think about that if that makes sense to you. If you have 8 rotations in a whole second, if you only have a fourth of that, it would be 1/4 of 8 or 2 rotations. So it's going to go around twice in a fourth of a second. Well, think about how many degrees does it take to go around a circle once? Well, that's 360 degrees, right? So if we go around once, it would be 360. So if I go around twice, that would be 720 degrees. So you can actually figure out a lot of different things about rotation if you think about what angle measurement you're talking about. All right, so I'll do this number 13 too, because these can be kind of tricky for people. A wheel makes 366 revolutions per minute. Okay, so that's the same thing as rotations per minute. So revolution, that just means once around as well. How many revolutions does it make per second? Well, this is just a conversion then. It's 366 per 1 minute. We're going to just multiply by our conversion factor here. How many revolutions would it make per second? So 1 minute is 60 seconds. Just multiply that through. So 366 divided by 60. And I don't think that's a whole number answer. It's about 6.1, I think. And that would be revolutions per second. Now, we could figure out how many degrees that is, right? We could multiply by 360, but they didn't even ask us. They just said how many revolutions. So that's how many revolutions there would be. So just getting comfortable with understanding how those numbers work. Okay, we're going to do some angle relationships now. So I'm going to do a few of these. I might have you solve the equations. I might just set up a few of them with you so you can go back and solve them. Use properties of angles to find the measure of each angle. So here are 2 angles, and they want you to find the measure of them. Notice below, they're just going to label them with letters, but they give you expressions for them. So one thing I'm going to ask that you do right away is go ahead and put those expressions in on your picture. Don't just hope that you can kind of follow that all the way through. Put it in on your picture. If they give you some information, plug it in. It's so much easier. All right, so it says, hey, what would be the measure of each of these angles? Well, these are called vertical angles. I know I mentioned those before in the video we had earlier this chapter. So vertical angles, they're congruent. They're equal to each other. They're always the same because they're going to have that same angle measurement going across there. They kind of make a V. That's why they call them vertical angles. They look like a V on each side. So they're going to be equal to each other. So the relationship here is 4x plus 7 is equal to 2x plus 39. And then your job is just to solve for x. Now, when you solve for x, and again, when we do that, that's not the angle measurement then, that's the value of x. Then you have to plug that back in. So variables on both sides, think about how you'd solve that. Go ahead, pause the video, solve for x here, and then we'll put that number back in. So we'd subtract the 2x. So 2x plus 7 is equal to 39. Then we would subtract the 7. So 2x is equal to what? 32. And then divide by 2. So x equals 16. Now, a lot of people pick that wrong answer of 16 degrees. It is not. That's what the value of x is. And again, I have to substitute that back in. Now, in this case, you could really do an either, right? They're equal to each other. Pick the one that you think is easier. It doesn't matter. So if I do 4 times 16 plus 7, that's going to give me the value of each of those angles. So 4 times 16, and then plus 7 looks like 71 to me, I think. So that means they would both be 71 degrees because they're equal, right? They are congruent angles. So we want to be careful that we're writing the expression, solving, but then realizing I have to plug that back in. All right, let's talk about the relationship for the next ones here. And then hopefully I'll help you set them up, and then you can go ahead and solve, and then don't forget to plug those numbers back in. All right, first order of business, put in the values that they're giving you. So this angle A is 3x plus 10. And then angle B is 4x plus 114. Okay, now what's the relationship between those two angles? If you go back to your notes here, these are parallel lines. They're on the same side of this transversal, we call it, that cuts through both of those parallel lines. So they're same side, interior, because they're on the inside. What do we know about same side interior angles? Well, one of them is acute, the other one's obtuse, so they can't be equal to each other. What they do is they add to 180. So 3x plus 10 plus 4x plus 114 is equal to 180 because they're same side interior, right? One's acute, one's obtuse. You have to just know the relationship. If you know the relationship, you can write the equation. Okay, so what I'm going to have you do on this one, go ahead, put your like terms together, solve for x. And once you have solved for x, remember you're going to have to take that number and plug it back in to both of those expressions for x so you can get your two angle measurements. So I'm just going to help you set up the equations, and then you guys can go back and solve and finish those up. Okay, number 16. So again, we have a relationship here. It says find the measure of the marked angles. So they want you to find the A, the B, and the C. So they're telling you some expressions. So they put the 1 in here up here. This is 2x. A down here is x plus 2. And this one is x plus 126. Do not assume that these things are to scale. They probably are not. So obviously in this one, they're very different angle measurements. So, but we do know something about what all three angles in a triangle add up to. So the angles in a triangle always add up to 180 degrees, right? So if I can write this expression, all three of these angles added together should be equal to 180 degrees. All right, so where do we go from here? Well, we're going to simplify this expression. So again, these are both counting for 1. So 2, 3, 4x, and then put together your whole numbers, plus, that would be 128, is equal to 180. Now you're going to, again, solve for x, right? Get your value for x, so just solve that equation for x. And then to find your angle measurements, remember, you've got to plug that x value back in to all three of those expressions to solve for the three angles. So remember, the x value is not necessarily going to be one of the angle measurements. You have to plug that value back in. So go ahead and plug that back in so you can see what you're dealing with there. And then you can check your answers on the solutions. So those are posted in Schoology. All right, let's take a look at a couple more here. So we'll just get a few more of these set up, make sure you're okay, and then we'll finish this up. Similar triangles. So we talked about the relationship between similar, where the angles are equal and the side lengths are proportional. This is a huge thing to be able to put in the numbers. They just have all of these letters that's so confusing. You can probably see that side A and side D correspond to each other, C and X do, and then E and B. But gosh, it's super helpful to get your numbers in here. So A is 12, B is 15, C is 6. That's on the little guy in there. The D is the 4. And the E is 5. All right, now you'll notice I did something here. I did the corresponding ones in the same color. That's really helpful. Make sure you label your picture, but the corresponding sides are the same color just to help. See what they want you to find. Find the missing value. They want you to find the X, which is on the bigger triangle. It's the only number you don't know, and it corresponds to side C. So I would say X is to 6 corresponding sides, as you could pick either of the other pairs. It doesn't matter. You can do 12 is to 4. You could do 15 is to 5. You can choose. It doesn't make any difference. They're both corresponding sides. But remember, the X is on the larger triangle, so that means the 12 should be on top corresponding to that X over 4. Now, a lot of people can kind of just figure this one out by looking at what's happening, but again, cross products are equal when we're talking about proportional. So 4 times x is equal to 12 times 6, which is 72. And then we just divide by 4. And we get x equals 18. So that missing side length that we need is actually an 18. So similar triangles, we just have to be careful that we know what's proportional. So that's an important part of our conversation. For number 18, I just want to draw your attention to the fact that they kind of flip the triangle over, but your corresponding parts, hopefully you can still tell what corresponds to each other. They're talking about the angle measurements. So angle A and angle X, they have it marked. These correspond to one another. So they said that angle A is 52 degrees. So that means angle X is also 52 degrees. That's what they're telling you. And they want you to find the measure of angle Z. Well, angle Z is this one. Don't really need much other than that these two triangles were similar. So you knew their angles were equal, because in this triangle, I think we have everything we need now. Remember, the sum of all 3 triangles adds up to 180. I know that this is 90 and that's 52, so I'm going to be able to find that third angle. So some people go ahead and subtract from 180 the other 2 that they know. Some people just say, oh, well, if this is 90, these 2 then together must be 90. They are complementary. So some people just do 90 minus 52. Either way, you should be able to get that measure of that angle, which comes out to, go ahead and type that in, 38 degrees, I believe, which is, oops, letter A. So it's all about finding out the relationship. Okay, we're going to do a little bit with, again, proportional triangles or similar triangles. So we did a couple like this in the notes. I'm going to encourage you to draw these 2 triangles separately. I'll take a look at number 19. How many right triangles do you see? Well, I see 2. I see this purple one here, and then I see this red one. So I want to draw those separately. So the purple one, this smaller one, the shorter one, the height is X and then the base is B. Now again, they're giving you information over here, so please put those numbers in. The B is 75, so I'm actually going to write that as a 75. I don't know the X, that's what I'm trying to find. In this red triangle, the bigger, taller one here, the C value is 40. So go ahead and let's put it in as a number. This B was 75 and the A was 25. So make sure, again, you label it. What is the entire length of the base then? Well, it's going to be 25 plus 75, which is 100. A lot of people make the mistake that they just say it's 25. That doesn't make sense for the picture, right? It's the bigger triangle. It should be longer than 75. So just be careful. And then now you should be able to set up a proportion corresponding sides. So you can say X is to 40 as 75 is to 100. That's one way to set that up. So we can say the height is to the height as the base is to the base. And again, corresponding parts here, we have the smaller triangle on the top, so the smaller triangle's on top, and go ahead and solve for X. So it's all about what's similar, what sides correspond. All right, for number 20, you're going to have to draw a picture, and we did ones like this before. You have a tree that's casting a shadow. At the same time, a statue is casting a shadow. So you want to have that picture representing what's happening here. So we have a tree casting a shadow, and then we have a statue casting a shadow at the same time of day. So the shadows are going to be coming from whatever the angle of the sun is, but they're casting a shadow at the same time of day. We can put in all the numbers that we know. So the shadow of the tree is 31 meters. Let's see, the shadow cast by a 41 centimeter tall statue is 79 centimeters. They told you the height of this statue is 41 centimeters. It's not very tall. And you're trying to find the height of the tree. So you don't know what the height of the tree is. So your missing piece is this. I don't know what the height is. So where the triangles come into play here, if you think about the height of the person, we can finish off the triangle. It would be kind of from the top of the statue down to the base of where that shadow stops. So really you do have similar triangles here. Oops. So you both have a right angle. These angles would be the same to the sun because they're casting a shadow at the same time. That's important. If it was different times of day, we wouldn't be able to say that they're similar. So we can set up proportion again here. So we have height is to the height as the shadow is to the shadow. We can solve pretty quickly. So the height is to the height as the shadow is to the shadow. And we can just cross multiply and divide. So I'll let you finish that one up as well. Be sure you're solving carefully there. So it's just making sure we have corresponding parts and reading through carefully. It's kind of confusing the way they said that. So make sure you can find those. We're going to go ahead and skip number 21. We're not going to worry about that one. And I want to talk about the SOHCAHTOA ratios for this last part. Make sure we talk about a couple of these. You're going to have your list for sine, cosine, tangent, and cotangent, making sure you know what those are. I'm going to jump down here and just write my little SOHCAHTOA reminder. Oopsies, that's an A. So if we think about what the ratios are, just a quick review of that. Sine of an angle measurement is equal to the opposite over the hypotenuse. Cosine of an angle measurement, I'm just using that Greek letter theta for angle, is adjacent over hypotenuse. Remember, these are all just ratios in a right triangle. Tangent of an angle, it's always of an angle, have to have with respect to something. We need our perspective, is opposite over adjacent. If you remember in our pictures when we drew these, we talked about things like the X, the Y, and the R. The X is the height or the horizontal, the Y is the height, and that R is that hypotenuse. So if we put in our words that go with that, this would be opposite, adjacent, and hypotenuse. So the other way we talked about these is we talked about them as a ratio of letters. So sine is opposite over hypotenuse. That would be Y over R. Cosine is adjacent over hypotenuse. So that's X over R. And then tangent is opposite over adjacent. Remember, it's the same as slope. So Y over X, like rise over run. Each one of these then have a reciprocal function that we talked about. So I'm going to do the reciprocals real quick too. So sine, the reciprocal is called cosecant, CSC. So if sine is opposite over hypotenuse, that's hypotenuse over opposite. So that means it would be R over Y. Cosine, its reciprocal is called secant, SEC of theta. So if cosine's adjacent over hypotenuse, this would be hypotenuse over adjacent. So that would be R over X. And then tangent, its reciprocal was called cotangent. So if tangent is opposite over adjacent, this would be adjacent over opposite, which is X over Y. So this was kind of the key information that we talked about for these. And remember, when we go into different quadrants, things will be positive or negative. So thinking about if you're in quadrant 1, we have positive and positive, negative, positive, both negative down here in quadrant 3, and then positive, negative. So keeping track of what sign your X's and Y's are as well. All right, so let's take a look at what we did for this, and I'll kind of jump back down to that. We always draw the picture first. So I'm going to go ahead and just kind of spot check a couple of these, make sure you're okay. We'll do a couple. I'm going to go ahead and graph the point here. So it's negative 10, 24. So that would be in quadrant 2. So negative 10, we're going to go in that direction, and up 24. I'm not going to draw this to scale, but this is the point that that terminal side is going to go through. So the angle that we were talking about here is measuring starting at the positive x-axis, and it goes through, that terminal side goes through that point at negative 10, 24. Now I'm going to go ahead and draw the triangle then associated with this. So we're talking about the perpendicular down to the x-axis, back over to the origin, and there's your hypotenuse. So the right angle is always on the x-axis. So what are the dimensions of this triangle? I'm going to go ahead and draw it in purple kind of separately here so we can just focus our attention. This distance is negative 10. I know that seems weird, but it just means left. We went left 10, and the height was 24. The first thing that we have to solve for is that R, the radius. Remember how we did that? This is a right triangle, so it's the Pythagorean theorem. So negative 10 squared plus 24 squared equals R squared. Be super cautious when you square a negative. A negative times a negative is a positive. So that is going to be a positive answer. So we would have, looks like 124 squared. And I think that adds up to, yep, 676 altogether, and then square root of 676 would be 26. So our radius is 26. Remember, the radius is always positive. It's the distance from the origin out to your point. It's the x's and the y's that can be positive or negative depending on the direction that you're traveling. All right, so which one do they want us to find? They want us to find sine of theta. So here's our triangle. They want us to do sine of that angle. And remember, sine is y over r, or opposite over hypotenuse, whichever way you want to think of that. So y is 24, and the radius is 26. Notice both of those numbers are positive. Now what I would do is I would actually reduce that down if you can, simplify. These are both divisible by 2, so divide them both by 2, and that would give me 12/13. So I would go ahead and simplify that down if you can. So it's just a little bit easier way to look at that. So you're always drawing the picture first and then talking about what's happening for that ratio. Okay, I'm going to do a couple more of these because I know this is tricky for people. So I'm just going to talk about a couple more here to set that up. So let's do 23. I'm going to go ahead and draw the triangle. So 9/12. That's going to put me in quadrant 1. So I'm going to go over 9 and then up 12. Again, probably not to scale here, but over 9 up 12. So the angle that they're talking about goes through that point. All right, so what is the triangle here then? Drop the perpendicular back down. So the dimensions of this triangle, the base is 9, the height is 12. This is my theta that they're talking about. And again, I don't know the r. So the first thing you should do is find the radius. So 9 squared plus 12 squared equals r squared. And go ahead and simplify. And I believe we get 130 or 81 plus 144. That would be 225. Square root would be 15. So my radius is 15. So you just have to find that third side. Always do the Pythagorean theorem. And now they want us to find cosecant, CSE. Remember, cosecant is the reciprocal of sine. You can go back down to our little list here. So r over y. So I'd be doing the radius over the y value. So the radius was 15 over my y, which was 12. And again, if you can simplify that, we'd want to simplify that down. So we can divide 15 and 12 both by 3. So that would simplify down to 4, or pardon me, divide both by 3. So 5 over 4, 5/4. All right, we're going to do one more here, and I'm going to let you finish up 25. Let's take a look at 24. 0, -3. So this one's kind of tricky for people. 0, -3, if I graph that, that's on actually the y-axis down here, 0, -3. So my x value is 0, my y value is -3. The angle that we're talking about is this one. It's right on the y-axis. It doesn't really look like there's a triangle anymore, but you can still find your radius. You still do the Pythagorean theorem. 0 squared plus -3 squared is equal to r squared. And what you end up finding, 0, 0, -3 squared is 9. So 9 equals r squared. Square root, that means r is 3. In other words, the distance from the center out to that point is 3 units, and that's all we're saying there. So the distance from the center is another way to think about what that radius is. It's how far out you are from that value. So now I can do whatever ratio I want. They want tangent, so I'm going to go ahead and write that over here. So tangent of the angle is equal to y over x. Well, y is -3. The x is 0. Can you divide by 0? No. So this one's undefined. And if you remember, we had several like that where we didn't have values. And that's okay. When we do those ratios, sometimes they do come out to be undefined. I'm going to let you go ahead and try number 25 on your own to make sure you're okay with doing one of those. You can check your answers then. I just want to talk about what the idea is for the last 3 here. It's just saying, hey, is my answer going to be positive or negative? So it's telling you the quadrant that you're in. So for this first one, 26, we're in quadrant 2, which puts us over here. And think about what you know over there for our ordered pairs. X's are negative, right, because we went to the left, but the Y's are positive. And remember, the R is always positive because it's the distance from the center. So those are always positive. So they're asking you to calculate a ratio. They want R over X. Well, R over X, if the R is always positive, X's in quadrant 2 we know are negative. What happens if you take a positive divided by a negative? You're going to get a negative answer. So it's just making sure you know how to find the signs of your answers. So lots of really big ideas here in chapter 14. You have a few left to go back and finish up and solve. Please finish those up, check your answers, and we'll see if anybody has any questions.